All right, in this video, we're going to do number 3 from the 2021 Calc AB and BC exams. And this is the, it instantly became famous as the spinning toy problem. And it's really not that bad. So let's see if we can do it. It reminds me of a problem from a while ago. I don't remember what it was, but you had to rotate something around an axis and it freaked everybody out. So I don't know, maybe if you're a teacher listening to this, we need to do a better job on that. So here we go. Company design spinning toy, it doesn't really matter. You're given a function, you're going to rotate around the x-axis. That's like what's happening. But a spinning toy using the family of functions y equals cx radical 4 minus x squared. C is a positive constant. Oh, all the way through when I was doing this, I was wondering if C was positive. I should have just reread it. The figure above shows the region in the first quadrant bounded by the x-axis and the graph. Each spinning toy is in the shape of a solid generated when such a region is rotated about the x-axis. Both x and y are measured in inches. I don't think I ever used that fact. Maybe I was supposed to put units on something, but I don't know. All right, A, find the area of the region in the first quadrant bounded by the x-axis and the graph when c is equal to 6. So this is just straight up a definite integral. We do need to know what are the bounds, right? So that's going to be when our function equals 0. So if cx root 4 minus x squared is 0, then either x is 0 or x is 2. I didn't do a lot of math on that. I just kind of looked at it and was like, oh yeah, so the square root of 4 minus x squared has to be 0. X would have to be 2 or negative 2, but we're in the first quadrant, so 2. So this problem we're going to do, c is equal to 6, right? So we're just doing the integral from 0 to 2, 6 times x root 4 minus x squared dx. This is like very close to a perfect integral. I'm going to take the 6 out. Now, if I in my mind, I'm basically letting u equal 4 minus x squared, right? So then the derivative of that is negative 2x dx. There should be a negative 2 on the inside. To balance that, I'm going to put a negative 1/2 on the outside, keep the bound 0 to 2, put a negative 2 on the inside, and then have x root 4 minus x squared. What I just did was I made it a perfect integrand. And negative 1/2 and negative 2 multiply to 1, so it doesn't really change anything. It just changes the way it looks. And in calculus, we do that a lot. So 6 times negative 1/2 is negative 3. And then basically what I have at this point is u to the 1/2 du. So I add 1, I get 3/2. So the reciprocal of that is 2/3. And then u, which is 4 minus x squared, to the 3/2. And we're going to evaluate that from 0 to 2. I make a lot of mistakes on this one when this type of problem. So I'm getting negative 2. It's when you zero out the first one, right? You plug in 2, you get 4 minus 4 is 0 to the 3/2. So you just get 0 to the 3/2, which is 0. And then minus, when you plug in 0, you get 4 to the 3/2. Now, this is a non-calculator question, so you can stop right here. There's no reason to really simplify this. I'm going to keep going. So it's negative 2. And then the square root of 4 is 2. Cubed is 8. So it's negative 8. And so overall we get 16. The units on that would be square inches because you're doing inches times inches. Maybe I was supposed to put that. I don't really know. It doesn't say like indicate units of measure, so I don't think there's a point associated with it. Probably should have done it though, but I didn't, and I'm not going to add it in right now. So let's look at the next part, which had a lot of people flummoxed. It is known that for y equals blah, for the given thing, the derivative is c quantity 4 minus 2x squared over the radical. For a particular spinning toy, the radius of the largest cross-sectional circular slice. So that's like a lot of words, right? You're going to rotate the curve around the x-axis. As you rotate it, this is the radius. And all this is saying is that radius goes up to 1.2. So what we want to do in this problem is we want to find the value of c that makes this true. Well, I need to figure out when this generic function has a maximum, right? Because when it has a maximum, that's going to be the maximum radius we could have. And at that x value, I need to make sure that the y value is 1.2. So that's the game plan. First, we're going to figure out where this given curve has a maximum. That, I think, is why they've given you the derivative. We need dy dx equals 0. So that means that c times 4 minus 2x squared over the radical thing equals 0. You can cross the denominator out and you can divide by c, so we basically end up with 4 minus 2x squared equals 0. Subtract 4, divide by negative 2 gives us x squared is 2. And if x squared is 2, then x is either plus or minus radical 2, but we're in the first quadrant, so x would just be radical 2. Now, do I need to justify that this is a relative maximum? I wasn't entirely sure, so I did it. So I'll just show it. So I said, since dy dx changes positive to negative at x equals root 2, y has a relative maximum there. I should have probably said an absolute maximum. It's the only critical point, therefore an absolute maximum. Seemed like a bit much. I don't even know that you need to do that part. But we do know that the largest cross-sectional circular slice, the radius is 1.2. So the radius is just y. So we're saying that 1.2 is equal to c times root 2, 4 minus root 2 squared. Plug in root 2 everywhere you see x, because that is the x value where you're at a maximum. Plug in 1.2 for y, because that is the maximum radius. Now we just have to solve this. This turns out to be 2c is equal to 1.2. And so I am getting that c is 0.6. That is the answer. It's really not that bad. It just sounds bad. First tip off for me was that they were giving me the derivative, so I definitely was going to need to use it. And then I think that if you think about it in terms of we're rotating this thing, so we're getting this radius, which is the purple segment that I drew, they're just telling you that that radius is 1.2. Figure out the x that makes that happen and solve for c. So you do have to think about it a little bit, and it is kind of a new-ish idea. But hopefully you're okay with that idea. Think it through again. Let's take a look at the next one. For another spinning toy, the volume is 2 pi cubic inches. What is the value of c for this spinning toy? All right, so we're going to just rotate around the x-axis. So that's going to be pi, the integral from 0 to 2, of cx root 4 minus x squared dx, right? So it's pi, the integral of the radius squared, and then dx. Pi r squared dx. So this has to equal 2 pi. So like right off the bat, you can just divide by pi, and you get the whole thing equals 2. I'm going to square the inside. So there's going to be a c squared, which is a constant, so I pull it out. And on the inside, we get x squared, and then the radical squared is just the quantity 4 minus x squared. And that equals 2 because we divided by pi. Let's actually do, now it's just fundamental theorem. I'm going to expand the integrand, because I don't know how you would do it otherwise. So we get 4x squared minus x to the 4th. This is just me doing the fundamental theorem for a little while here. C squared, 4/3 x cubed minus 1/5 x to the 5th. So at this point I start thinking like, this is going to have a really messy answer. Or they did something genius where it's going to work out really nicely. So we got to plug in 2. When you plug in 0, you just get 0. So when we plug in 2, we get 4/3 times 2 cubed is 8. So that's going to be 32/3. 2 to the 5th is 32. So that's minus 32 over 5. So now I start thinking maybe they did get an amazing, clever thing. But they didn't. I'm going to take the 32 out and have 32c squared. And then it's 1/3 minus 1/5. So we can get the common denominator there and just have 5 minus 3 over 15. I don't know. I'm just telling you how to do arithmetic here. That should equal 2. So this is going to give us, you get 2 times, I did way more math here than I needed to. We get this. And then, so c squared is 15 over 32, which means that c is, it's either plus or minus, but they tell us that it's positive. So it's the square root of 15 over 32. You can just leave that. I mean, that simplifies to something, obviously, if you're like a rationalize the denominator type of person, but you don't need to be. So I would just leave that as it is. And that was it. That's the spinning toy problem that everybody's freaking out about currently right now. So I hope you found this helpful, and good luck.